Hi. Now, in this example, we're given that f is a function such that x maps onto the natural log of 4 minus 2x. And x is less than 2, and it's also a real number. And what we've got to do is show that the inverse function, that's f to the minus 1, is such that x maps onto 2 minus a half e to the power x. So you might like to pause the video if you want to have a go at this and come back and I'll run through the solution. Okay, well, let's just see how you might have got on with this. Well, first of all, when we're finding inverse functions, what I would always suggest you do is just say let, and we write down x equals, and wherever you've got x's in your function, replace them with a y. So in this case it's going to be x equals the natural log of 4 minus 2y. Now what we need to do is rearrange this and make y the subject. So if we anti-log this, get rid of the natural log, then what we have is that therefore e to the power x equals 4 minus 2y. Just in case you're a bit worried about that step, I'll just remind you basic log rules, okay, that if you have the log of any number, let's say n in a particular base, a say, and it equals x, then you should know that n equals a to the power x. So we're dealing with a special log here in a special base. It's called natural logs, so that is logs in base e. So wherever you see an a, it is now an e. So hopefully you can see that that number, in our example it's 4 minus 2y, equals e to the power x. Alright? Okay, well, let's just carry on now, making y the subject. So what I'd want to do now is say add 2y to both sides, and if we do that we've got 2y plus e to the x equals to 4, and then subtract e to the x from both sides and you're left with 2y equals 4 minus e to the power x, and then divide by 2, so therefore you end up with y equals half of 4, which is 2, and then we'll just write minus half e to the power x. So you can basically see that we're getting what we needed to show here. Only I need to finish it off in this style, so therefore the inverse function of f to the minus 1, is such that, and then we can just write that x maps onto, okay, 2 minus a half e to the power x. And as for the domain of this function, this is going to be valid for any real value of x. So we can say that x is any real number. Okay? Well, I hope you've been able to follow that, and that brings us to the end of this particular tutorial.